Now that we've been looking at logarithms, we also want to look at some known properties of logarithms. These properties really come into play when we're solving logarithmic equations. We can use these properties to help us solve or simplify an expression. We'll also use them quite a bit next year in calculus when we start looking at doing some differentiating and integrating with logarithm and natural logarithm functions. So the properties are that if you have a logarithm of a product, you can break the product up and give each of it its own logarithm and add those logarithms together. If you're dividing, break it up and have them each subtract. And then if you have a exponent or a power on whatever it is you're taking the logarithm of, you can move that power or that exponent to the outside. Because ln, or natural logarithm, is a type of logarithm, these same rules apply if you have base e. We're going to look at 4 different ways we can use these now. So there are going to be 4 different types of examples. So please do make sure that you watch this entire video in order to make sure that you're able to perform the work that goes along with this in class. One of the things we can do is we can use logarithms or the properties of logarithms to express logs in terms of their prime factorization. So let's say I wanted to do that with letters A and B here. So think back to pre-algebra type times. How do I rewrite a number in terms of its prime factorization? Well, that's where we had those factor trees. So I could say 75 is 25 times 3, and 25 is 5 times 5. Therefore, this gives me ln of 3 times 5 squared. Well, now notice what I have. I have a product here. So if I have a product, I can break that up and add. So that will give me ln of 3 plus ln of 5 squared. And once again, notice that now I have an exponent. What do I do if I have a power or an exponent? I bring that out front and change to multiply. So I have ln of 3 plus 2 times ln of 5. My directions had asked me to express in terms of either logs of 2 or logs of 3. So notice I have a log of 3 and a log of 5. So I probably need to change those directions. I cannot change this to log base 2 because there is not a prime factorization of 2. Looking at letter B, I'm going to do the same thing. So I look at 32 and 9. So in 32, when I make my factor tree, I know 32 is 4 times 8. I know 4 breaks down to the primes of 2 and 2. 8 into 4 and 2. Then 2 into 2 and 2. Notice you stop once all you have left are primes. So I have 1, 2, 3, 4, 5 2's. 9, of course, breaks to 3 times 3. I only have 2 of those. So this becomes log of 2 to the 5th over 3 squared. So when I'm dividing, I can go ahead and subtract as it shows up above. I am going to need some of this room where I did my prime factorization at, so I'm going to erase that to give myself some more room. And I'm going to go ahead and say that this is the same thing as log 2 to the 5th minus log 3 squared. And then taking one further step to bring those exponents out front, I will have my logarithms expressed, both of these in terms of their prime factorizations. Now looking at another thing we can do with these, we can also use these properties to simplify. So if I want to simplify this next example, I'm going to do something very similar to what I did above. I'm going to first notice that that cube root is the same thing as 1/3. So I'm going to bring that out here and say I have 1/3 log base 2. And why am I able to do that? Because a cube root, remember, is the same thing as a 1/3 power. So I'm using this power rule here. And I just saw that 32 is the same thing as 2 to the 5th, so I'm going to do that again, 2 to the 5th. Well, now I have another power that I can bring out front and multiply. So now I have, bring the 5 out, now I have 5/3 times log base 2 of 2. Well, I recognize that if I have a base and my log that I'm taking are the same, that's just 1. But let me show you here off to the side why I'm going to be able to make that 1. So let's say I ask myself log base 2 of 2 equals what? Equals some y. Well, if I change that to exponential form, wouldn't that mean that 2 raised to the y equals 2? Therefore, this expression here has to be 1. So if that were 1, that would mean this would become 5/3 times 1, which would just be 5/3, which is much simpler than having a logarithmic equation or a logarithmic expression. Let's look at example 3 here, or my next example underneath example 2. Okay, I'm going to do something very similar to what I just did. I'm going to go ahead and say I can bring the 4 out in front and I can bring the 2 out front. When I do, I will have 4 times 3 is 12, ln e, minus 2 times 2 is 4, ln e. Well, remember what just happened when I took base 2 of 2? Well, isn't ln the same thing as base e? So now aren't I doing the exact same thing as I just did and taking base e of e, base e of e? Or if I try to make that a little bit more clear here by looking at a little setup on the side, aren't I saying that ln or log base e of e equals something and changing to exponential form? E to the what equals just e? Well, once again, I would have e to the 1. So I can say that this entire expression is just 1. So, and log base e of e is the same thing as ln. Therefore, I have 12 times 1 minus 4 times 1, which gives me 12 minus 4, or 8, as my final answer. Let's look at another way we can use these properties. Another way to use these properties is to expand our expressions. This is probably the most important use of them, especially when we get into calculus next year. So let's look at, there's 2 examples under here, so let's look at these. So looking at the first one, if I want to expand it, well, I know you can't see my properties here, but hopefully have them on your own notes that you're following along on. I see that if I'm taking the logarithm of a product, remember I can break that product up and add all those various logarithms. So I'll have ln of 4 plus ln of m cubed plus ln of n to the 5th. So now I can take that power property and move my 3 and my 5 out front, giving me ln of 4 plus 3 ln of m plus 5 ln of n, and that's as expanded as I can get. Got everything have its own separate logarithm. Let's look at another example like this. So again, now I notice that I'm taking the logarithm of a quotient. So I'm going to go ahead and break this quotient up by looking at my properties and seeing I can subtract, and that gives me log of 2x minus 3. I do need to keep the parentheses to show I'm taking the log of that entire quantity, minus log of 3 times, and I'm going to call that x to the 1/4. The next thing I notice is I have a product here. So again, looking at my list of properties, I see I can break a product up into addition. But I have to acknowledge the fact that I was subtracting this entire quantity. So when I rewrite it as addition, I still have to show I'm subtracting the entire quantity by using parentheses. So I'm going to go subtract parenthesis or bracket, whichever you prefer to use, log 3 plus log x to the 1/4. From here, I'm going to go ahead and bring my 1/4 out to the front. I'm also going to distribute my minus sign, so I'm going to do 2 steps in one here, giving me log of 2x minus 3 minus log of 3 minus 1/4 log of x. And that is all I can do. You do want to be careful that I'll see people try to break this, but notice that I can only break it into individual logarithms if I'm either multiplying or dividing. And even though I have multiplication in here, it is combined with that subtraction, so I don't have any rules that allow me to do anything with subtraction. Alright, glad you were able to stick with this video. I am on to the last way we're going to use it, and that's to condense or put expressions smaller or back together. There's 2 examples with this. I'll try to get through them fairly quickly. First thing I notice on this one is I have a couple of coefficients I can bring up front to exponents, giving me log base 4 of x to the 1/2 minus log base 4 of x minus 2 cubed. And I also notice that since I am subtracting 2 logarithms, I can put them back together with division. And I have log base 4 of x to the 1/2. I would prefer to write that as the square root of x. It does not really matter though, personal preference, over x minus 2 cubed. And now that I have it as a single logarithm, I have condensed that. Last final example here. Again, I'm trying to condense or put them together as one logarithm. So first thing I'm going to notice is I have a 4 here that I can bring up as an exponent. Now, I start to recognize, or as you start to recognize these properties and see them, I see that I have divide, divide. It is very weird to have divide, divide. That does not make a lot of mathematical sense. So I'm going to factor that minus sign out, since they both have a minus sign in front. The reason I find that helpful is now I notice that I can do what's in my parentheses here, and I understand that it's not divide, divide, it's multiply and then divide by that product. So I'm going to have ln of 3x plus 5 minus ln of x to the 4th times x minus 1. And now taking care of that subtraction, I get a final answer of ln of 3x plus 5 all over x to the 4th times x minus 1. And once again, because now I have a single logarithm, I have successfully condensed my expression. That's it for using these properties to do various activities to my logarithm expressions.